As comfortable as a 747, but able to land at almost any commercial airport. Introducing the new DC-10 luxury liner.
They were the elegant compromise of aviation engineering, 3 engines that promised the perfect balance of power range and economy. The DC-10L-1011, TriStar and Boeing 727. These magnificent trijet marvels once dominated our skies, taking passengers across oceans when twin-engine aircraft simply couldn't yet today look up. What do you see? 2-engine aircraft and the occasional 4-engine jumbo. The trijet has vanished. What forces eliminated what many aviation experts considered the perfect configuration? Was it regulation, technology, economics? Today we uncover the fascinating story behind the rise and fall of aviation's forgotten middle child, the trijet. Imagine it's 1968, commercial aviation is booming, but there's a problem if you want to fly passengers over oceans. Aviation authorities demand redundancy, extra engines for safety. That's why aircraft like the Boeing 707 carried 4 engines, making them fuel-hungry beasts. Boeing's answer came first with the 727 featuring that distinctive T-tail with its 3rd engine integrated into the vertical stabilizer. This unique configuration, it allowed operations from high-altitude airports and shorter runways that larger jets couldn't handle the 727. It wasn't just successful, it was revolutionary. Airlines worldwide embraced it, and Boeing, they sold 1,832 of them, a staggering number for the era. But the real trijet revolution that was just beginning for long-haul flights, the battle came down to 2 titans, the McDonnell Douglas DC-10 and the Lockheed L-1011 TriStar, both launched in the early 1970s, promising to deliver passengers across oceans. With the perfect balance of safety range and efficiency, have you ever wondered why these aircraft appeared simultaneously? It wasn't pure coincidence. American Airlines played a key role in shaping the demand for these aircraft. The airline sought a smaller, more cost-efficient alternative to the larger Boeing 747 capable of efficiently covering long distances with a significant passenger capacity. In response, both McDonnell Douglas and Lockheed developed their Trijet engine designs, the DC-10 and L-1011, to meet the needs of American Airlines and other carriers, ultimately reshaping aviation history. The trijet's initial success wasn't just clever engineering, it was regulatory genius. The FAA enforced what pilots called the 60-minute rule, limiting twin-engine aircraft to route never more than 60 minutes from an emergency landing field, cross an ocean, not with just 2 engines. This created the perfect niche for trijets. More economical than 4-engine aircraft, yet unrestricted by the limitations that hamstrung twin-engine design. With a 3rd engine, carriers could fly directly across the Atlantic Pacific or polar route, operating lucrative markets while burning less fuel than quad jets. The L-1011 was often described as the Rolls-Royce of the skies, featuring advanced avionics, remarkable flying characteristics, and the industry's first auto-land system certified for categories. Triple I approaches, meaning it could land in 0 visibility. The DC-10 offered flexibility that carriers loved, with variants optimized for different mission profiles, from dense domestic routes to ultra-long-haul international service. Both aircraft were technological marvels that pushed the industry forward, but their greatest innovation, that 3rd engine, would ultimately lead to their downfall. If there's one acronym that sealed the fate of the trijet, it's this EOS Extended Range Twin Engine Operational Performance Standards. It represents perhaps the most significant regulatory change in commercial aviation history. The pivotal question, what if twin-engine aircraft became so reliable that they no longer needed to stay within an hour of diversion airports? By the early 1980s, engine reliability had improved dramatically. Airtime between failures had increased exponentially, and aviation authorities, they reconsidered their stance in 1985. The FAA granted the first ETOPS 120 approval, allowing properly equipped twins to fly routes up to 120 minutes from the nearest suitable airport. By 1988, EOPS 180 became reality. The impact was immediate and devastating for trijets. Suddenly, the Boeing 767 and Airbus A310, they could fly almost any route a trijet would, while burning less fuel and requiring less maintenance. The 3rd engine, once a regulatory necessity, had become an expensive redundancy. It's not that 3 engines are bad. As one veteran pilot put it, it's that 2 engines got so much better. Consider this fact: a single modern GE9X engine, it produces more thrust, 134,300 pound force, then all three engines on a DC-1030 combined, approximately 125,000 pound force. That's not incremental improvement. It's a revolution as ETOPS ratings extended further. Eventually reaching 370 minutes, twin-engine aircraft could fly anywhere on the planet, rendering the tri-concept obsolete. The third engine, well, it seemed elegant on paper, but in practice it created complex engineering challenges. Let's start with the obvious. Putting a massive turbofan in the tail is complicated. The L-1011's design team, they faced a vexing problem how to feed air to an engine embedded in the vertical stabilizer. Their solution, it was an S-duct that curved through the tail feeding clean air to the number 2 engine. This engineering marvel, it came with costs, added weight, complexity, and maintenance challenges. Every pound of additional structure meant less payload capacity and higher fuel burn. The DC-10 mounted its tail higher on the fuselage with a straight inlet while simpler. This created its own issues, including potential pitch instability. Maintenance was perhaps the biggest headache of all. Imagine working on an engine suspended around 30 feet above the ground. Tasks that were straightforward on wing-mounted engines, they became logistical nightmares. You needed specialized equipment just to reach it. Recall one technician engine changes that took hours on a wing could take days on a tail. This complexity had some pretty serious implications. On May 25, 1979, American Airlines Flight 191 DC-10 lost its left engine after takeoff. From Chicago O'Hare, the engine separation severed hydraulic lines and caused wing slats to retract. The crash killed all 271 people on board and 2 on the ground at the time. The deadliest accident in US aviation history. While the accident resulted from improper maintenance rather than inherent design flaws, it highlighted the consequences of complexity. Airlines increasingly asked why deal with the complexity of 3 engines when 2 could do the job. By the 1990s, the airline industry was transforming. Deregulation had intensified competition, fuel prices were volatile, and profit margins. Razor-thin efficiency wasn't just desirable, it was survival. The Boeing 767-300R, it burns less fuel per hour than the DC-1030 over an aircraft's lifetime. The difference can represent tens of millions in operational costs. The math became unavoidable. McDonnell Douglas recognized the changing landscape, developing the MD-11, an advanced evolution of the DC-10 with winglets, a stretched fuselage, and more efficient engines. But the MD-11 faced a perfect storm. It arrived just as ETOPS approved. Twin jets were proving their reliability, and worse, it failed to meet its own performance. Guarantees the result. Just 200 million 11s were built before production ended in 2000. Airlines that had built their long-haul fleets around Trijets. They faced difficult decisions. British Airways, Singapore Airlines, and others began replacing their DC-10s and L-1011s with 767s and 777s. Even cargo carriers who previously embraced Trijets eventually surrendered to economics. FedEx, once the world's largest operator of DC-10s and MD-11s, began replacing them with twin-engine freighters, offering more payload with less fuel. The MD-11 is a workhorse, admitted one, FedEx fleet manager, but it's just not as cost-effective in the long run. There's a fascinating psychological dimension to the Trijet story that's often overlooked. For decades, passengers associated engine count with safety, more engines that meant more redundancy, a compelling logic that helped market 4-engine aircraft like the 747 as the ultimate in safety. When Trijet emerged, they benefited from this perception. 3 engines seemed safer than 2, and the aviation industry, they did little to discourage this belief. But was it actually true? The data, it tells us a different story. Modern twin engines, they actually achieved remarkable reliability. The probability of a dual engine failure on a twin jet, it's actually lower than losing 2 engines on a trijet. A Boeing 777, it could operate for over 100,000 hours without an in-flight shutdown. The odds of both engines failing simultaneously, they're astronomically low. I still hear it from passengers, said one captain who transitioned from the L-1011s to 777s. They look at these 2 huge engines and ask what happens if they both fail. I tell them that's like worrying about being struck by lightning while winning the lottery. This psychological barrier took years to overcome, but as twin-engine aircraft began routinely flying 15-plus-hour routes over remote regions, perceptions shifted. By the mid-2000s. The psychological advancement had eroded. Passengers cared more about modern interiors, entertainment systems, and service over the engine count. Today, passenger-carrying trijets have all but disappeared. The last passenger MD-11 flight, operated by KLM, touched down in 2014, marking the end of an era. A handful still fly cargo routes, others serve specialized routes, aerial firefighting, or as flying testbeds. The L-1011 was the most forgiving, smoothest handling wide-body I ever flew. Recalled one. Retired captain modern aircraft are more efficient, but they don't have the same soul. The trijet era lasted barely 4 decades, a brief chapter in aviation history, but one that left an indelible mark. Perhaps the most important legacy is what it taught the industry. The balance between redundancy and efficiency isn't static. As technology advances, that balance shifts. What made perfect sense in one era becomes obsolete in the next. So why did trijets disappear? It wasn't any single factor, but rather the confluence of regulatory changes, technological advances, economic pressures, and evolving passenger perceptions. The trijet solved a specific problem at a specific moment in aviation history: how to fly long distances efficiently when regulations restricted twin-engine operations. When that problem disappeared with ETOPS, so did the rationale for 3 engines. Could trijets make a comeback? It's unlikely. 2 massive, ultra-reliable engines, they're simply more efficient than 3 smaller ones. The physics and economics remain unyielding, yet there's something undeniably special about these aircraft. Their distinctive silhouettes with that 3rd engine nestled in the tail represent a unique period. When aviation engineers refused to accept limitations and found an elegant compromise that opened new possibilities, the next time you board a twin-engine 787 or a 350 for a 15-hour flight across an ocean, remember this: that journey, it was made possible in part by the trijets that came before aircraft that pushed boundaries, challenged the assumptions, and helped create the connected world we take for granted today. They may be gone from our skies, but their legacy flies on with every long-haul flight that crosses the globe. Did you ever fly on a trijet? Share your experiences in the comments below, and if you're fascinated by aviation's evolutionary, dead ends, and forgotten marvels, hit subscribe and the notification bell for our next deep dive into aviation history. Until then, keep looking up.